Let's explore the differences in neutral current behavior between 120 volts/208 volts and 120 volts/240 volts electrical systems. Understanding this distinction is crucial for accurate electrical calculations and safe installations. The core of the issue lies in how current behaves in these different systems when supplying power to multiple branch circuits sharing a neutral conductor. In a 120 volts/240 volt system, the two phases are designed to be balanced. Ideally, each phase carries an equal voltage of 120 volts, and loads connected to each phase draw roughly the same amount of current. When two branch circuits connected to opposite phases of a 120 volts/240 volt system carry the same current, the neutral current should theoretically be zero. This is because the currents from each phase effectively cancel each other out as they return through the neutral. Think of it like two equal forces acting in opposite directions. However, a 120 volts/208 volt system is different. In a 120 volts/208 volt system, it is a three-phase system where the voltage between any two phases is 208 volts. The voltage from each phase to neutral is 120 volts. The three phases are 120 degrees apart. In a perfectly balanced three-phase system, the neutral current would ideally be zero, even with loads connected to each phase. But in reality, loads are rarely perfectly balanced. This imbalance creates current on the neutral wire. In a specific scenario of two branch circuits, the magnitude of current in the neutral wire will depend on the phase relationship between the two. The phase angle between phases is what prevents cancellation, like in the 120 volts/240 volt system. If the two 120 volt branch circuits each have the same load, the current on the neutral would be the same as the current on each of the branch circuits. If there were three branch circuits each with the same load on a three-phase system, the current on the neutral would ideally be zero. Here's a more detailed breakdown. In a 120 volts/208 volt system, the voltage between any two phases is 208 volts, while the voltage from each phase to neutral is 120 volts. The phase angle between each phase is 120 degrees. Because the phases are 120 degrees apart, you must use vector addition to find the neutral current. You cannot simply add or subtract the current magnitudes. Consider the scenario where two branch circuits on a 120 volts/208 volt system each carry the same current. In this case, the neutral current will not be zero, it will be the same magnitude as each of the branch circuits. The reason for this is that because the two phases are 120 degrees apart, the currents do not simply cancel out, instead requiring the use of vector addition. In contrast, with a 120 volts/240 volt system, when two branch circuits on opposite legs have the same current, the currents are 180 degrees out of phase. These will cancel each other out on the neutral conductor, resulting in no net neutral current. In summary, while in a balanced 120 volts/240 volt system, equal currents on opposite phases result in zero neutral current. In a 120 volts/208 volt system, the phase angle between the branch circuits will result in the neutral current being the same magnitude as each of the branch circuits.